Hello, hello.
Hello.
Let me turn off the waiting room. I don't have to deal with that. Hello, hello. How's everyone's day going?
Good.
It's good to hear. I think we're gonna get started in about probably like 1 more minute. Just see if anyone else comes in. But since we are kind of limited to 1 hour, try and get started pretty early. While we're waiting though, does everyone have access to the 001 plus I guess training site with all the lesson plans and stuff? If not, let me see if this link works. But hopefully you guys can all take a look at this. Let me know if that doesn't work. Okay, so hopefully that link is working for everyone. All right, nice. Okay, so welcome to Scratch 001 Plus. This, I guess, section of Scratch focuses entirely on games, which, in my opinion, captures the attention of children a lot easier than a bunch of other random projects. And with that being said, one thing I want to mention now, and I'm going to keep mentioning it for the entire hour, is we want the kids to stay interested. So our primary objective is not necessarily to teach them new content. That's usually naturally going to come. The main focus is keeping them interested and keeping them motivated to continue adding on to projects or starting new ones. Another thing you're also probably going to notice is people coming into this class are going to be at a variety of different skill levels. You might see someone coming into this class who's never touched Scratch in their life, and then you might also see someone who's been playing around with it for maybe a year or two. So I guess first let's get started by taking a look at level 1, the units 1 through 4. Just take a look at the maze game. Go ahead and screen share. Okay. So this project is relatively simple, and it's designed to be so. Because on your first couple days of class, we want to find out what skill level everyone is on approximately. If someone is completely new to Scratch, that's okay. You're probably going to have at least one in your class, so you're going to have to slow down in order to accommodate that. So the first project is a very, very simple maze game where we have basic movement code. That can just be like arrow keys going up, down, left, right, and a little bit of, I guess, creative freedom to the children. They can design whatever maze they want. They can add different power-ups, obstacles, and that sort of thing into the project to keep them interested. But during this time, you want to get to know how comfortable all the students are with Scratch as a, I guess, programming language. During your first class, I would say it's very much up to you how much of the icebreaker thing you want to do. Sometimes it's nice. One really good question to ask during icebreakers is what kind of games they play on their own. So sometimes the answer will be they don't play any at all. But usually they'll play something like Minecraft, like Roblox. And you can really use whatever they say during that time to influence what they create next. So if they're familiar with Minecraft, maybe you can say, oh, let's add something Minecraft-esque into your game. And usually that'll get them a little more excited. And that goes with the maze game as well. For those who are completely new to Scratch, this is your take the first couple classes to introduce them to everything that Scratch has. So you're probably going to have to go through all the code blocks, what types they are, go through the stage, go through the sprite creation, drawing things, all that kind of stuff. And I would say usually you can squeeze a quick introduction into the first class. And the maze game is a really good way to introduce them to basic concepts like these. And for all the students that are more comfortable with Scratch or very advanced, you could have them add more complex things, have them design things on their own. Before I keep going, I want to ask all of you guys, how familiar are you guys with Scratch? Okay, I see one of these. I think it's relatively important that you are completely prepared for each class, especially if your students are bright and they are very creative and that kind of stuff. If they come into class and they want to do something and they ask you how, it's best to be able to respond to that easily. So if they want to design some new type of game mechanic, then ideally you come up with some quick way and then ask them leading questions to kind of guide them towards the answer. So for example, if they say, I want to create an obstacle that kicks you back to the start when you touch it, then hopefully all of you guys can think of something right now that would fulfill that, and then ask, perhaps, okay, so what are a few of the blocks that we're going to need, for example? Maybe you're going to need the sensing block, the touching, all that kind of stuff. Okay, so that's mostly it for the maze game. For all of these projects, there's a lesson plan here, which just a very general step-by-step on how you can teach the class, though please, please, please feel free to deviate from that. If it feels awkward, if you feel like your class would flow in a better way, it depends on the students in the class, of course. So you have a lot of freedom to steer off of this. Honestly, even if you want to make your first project not the maze game, that's completely fine as well. But these are just general guidelines that you can follow. And also, along with each unit, there's a example project. So this would download a Scratch file here. So if you go into Scratch and hit upload file, open this up, you will get a example, one that I've created before that you can use to check out the code, see what kind of code that is used, and so on. I believe there are also little notes inside those projects as well. Okay, so real quick, anyone have any questions right now? Okay. Feel free to stop me at any point, by the way. Next project, the platformer. So this project is obviously slightly, I guess, Mario themed. That's probably one very easy way that you can explain what a platformer is. And if the students don't know what type of games these are, so if I said maze game and they don't know what that is, or if I said platformer game, you can always pull up the example project and just show them a quick playthrough so that they know kind of what they're trying to create. But typically when you say a platformer, they'll know what you're talking about. If not, if you say Mario, they'll probably get it from there. All of these projects sort of build on each other. So maze game, simplest platformer, that's when you start adding in some new things, particularly variables. And in Scratch, we use a variable to, I guess, give you the first derivative of position. So for velocity and acceleration, you need to use variables to create convincing gravity. Obviously, don't explain it in terms of calculus. That'd be terrible. But with the gravity, that's probably the toughest part of the whole project. I think one really good way to explain it is using a real world example. Pretend like you're dropping something off a tower, and just kind of note how it falls faster and faster as it keeps going. And then slowly, using ideas like that, some things that they can connect to in real life, you can build up to the fact that, okay, so it's going to move down maybe one step at first, then 2 steps, then 3 steps, then 4 steps, and it continues to fall faster and faster until it hits some surface. And then using that, you slowly transition that into code, and that should give you gravity. But you can see, the first one is just give them the left and right movement. And here you can explain what the general goal of jumping is. So jumping is obviously moving up and then moving down. There's gravity. And I even created an extra slideshow to help with explaining gravity if you do want to take a look at that. It's a quick little Google Slides. And of course, you guys have access to all of this, I believe. If you don't, save that link because you're definitely going to need it. But there's some stuff in there for you guys to look at. And of course, an example project. So it's around this time that you want to mainly introduce more of the freedom part of this course. Throughout, obviously, you're following generally creating similar projects with the whole class. So everyone's going to create something that can move left and right. Everything's going to create something that can jump, fall down with gravity, and so on. But there are a lot of parts where you want everyone's projects to be slightly different. So for the platforms, normally you would just kind of squeeze them all onto one stage. You would have it all fit into one stage, which is that 480 by 360, so not super huge. One thing that you can add on here is creating like a scrolling for like if you get to the right side of the stage, then it goes to like another part of the level and so on. So you can kind of extend your level horizontally that way. Of course, power-ups, different types of platforms, like a platform that bounces you, one that like launches you up, a teleportation portal. Whatever the kids think of, I would say prioritize that first. If you
Dude,
get
see how
into
your mic's on.
sorry. Right, okay. So as you create new features, so we have a basic, a very basic base, I guess, where we have basic movement, jumping, etc. That's where you start adding on things, and everyone's project starts to become slightly different. So here, you want to encourage them to try and create something special on their own. A few common examples are different types of platforms. You can create some sort of an enemy that they have to somehow defeat or kind of get around, stomp on, like a Goomba and Mario, whatever that would be. And yeah, prioritize whatever they think of first. So you want to encourage them to think of ideas on their own and think of ways to add that into their own game. Usually they'll have questions, and so you're just going to help them along with that. If most of the children are not very talkative, well, actually, yeah, there's like two different cases here. There's the case where there's like one person that talks a lot. That's fine. It's completely good. If they throw out a bunch of ideas, you can kind of use those ideas to guide the rest of the class. So let's say they asked, let's create an enemy that we can jump on. So you would be like, oh, okay, that's really cool. Who else just thinks this is a pretty good idea? And if no one is blatantly against it, I guess you can move on with that, and then you can bring the class project, the one that you're doing on your screen share, etc., in that kind of direction. If a lot of people have different ideas and everyone is very talkative, then you would encourage each one with questions. And that's where you just kind of like split off into helping children more one-on-one. But usually for the rest of the class, you want to have some idea that you decide to follow on the main class project, the one that you're sharing with everyone. So you can pick one of those ideas, you can come up with one on your own, whatever it is. You want to have some sort of a guide for the rest of the class if they don't like any of those ideas, or they don't know what to do. And obviously in the case that nobody talks, you have a couple ideas here that you can certainly add. So if no one talks and you can be like, anyone have any ideas? Complete silence. You can say, all right, so let's try creating one of these then. And of course, depending on how comfortable the students are, these projects can get really complicated or they can stay pretty simple. But whatever it is, for the pacing, I know before it said like maze game 3 classes, platform game 4 classes, something like that. Again, that's really, really flexible. If you feel like classes are starting to drag, feel like people are starting to lose interest, then feel free, either introduce something new to get them excited, or if that's not working at all, go ahead, move on to the next project if you think that people are ready for it. And I guess if they're not ready for it and they're not interested, try and create a subgenre of a platformer. So something very, very specific that is engaging for them. Okay, so that is platformer. And here are the tower game Breakout. Before I go on, I do want to mention units 7 and 8. So I know not all of you are teaching level 2 necessarily, but there are 2 levels. There's level 1, which are these, relatively more simple, and then level 2, which are a bit more complicated. For units 7 and 8, if you do plan on teaching level 2, these require a Scratch account, like a fully verified Scratch account. So it needs the kids, either their own email or a parent's email to verify, and also they have to be active on their account. So to be considered what they call a Scratcher, you have to be somewhat active, as in you have to share some projects. You have to, I don't know if this is necessary, but I would stay on the safe side, like favorite some projects and just kind of browse around on the Scratch website. And I believe it takes like 2 weeks minimum, something like that. So ideally, early on, like very early on, you get them to create a Scratch account, and sooner rather than later, make it a Scratcher account. Because you have to be a Scratcher in order to use cloud variables, which are necessary for these two multiplayer online games, which are usually the most interesting. Right, that's just there's a little tangent there. Okay, back to the tower game. Once again, there's a presentation here for you, lesson plan and example project. This one is pretty, I guess it resembles Doodle Jump a little bit, where you're endlessly going up. And you can add in a lot of student creativity here. There's a lot of room for power-ups and such, different types of platforms, scorekeeping. You can do lives here, etc. I won't really spend too much time on this because this is relatively similar to the platformer. It uses gravity as well. And we're going to go to Breakout right now. So Breakout is based off of the old Atari Breakout game, where you have that paddle at the bottom, moves left and right, you bounce a ball, breaks bricks. So in this one's a lot more mathy. When your Scratch has a block called when on or if on edge bounce, which does a perfect bounce, but it only works on the actual edges of the screen. And here we want to be able to bounce off of different sprites as well. So for every brick and of course the paddle, it should be able to bounce off naturally. And here there's a little bit of math that you're going to need to explain. So pretty early on, you'll find out whether or not the kids are familiar with the coordinate system. So normally they are usually at least acquainted with it or pretty good at it. And I would assume you'd need to use coordinates much earlier on as well. But especially here, you need a lot more math. I think over here. So explaining how bouncing off the top and bottom walls causes the direction to flip. So you're manipulating the direction variable here that controls, I guess, which direction the sprite is facing. And there's two different cases, which is one where it bounces off or bounces vertically or bounces horizontally. They have slightly different formulas to flip them, but you can take a look at that in the example project here. So, by the way, as I explain this, feel free to take a look at the example projects. See if most of that makes sense. If it doesn't, please let me know. Okay. The first 4 steps are mainly to create the base game. So just breaking the bricks, and perhaps adding win conditions. So break all the bricks, you win. Miss the ball, you lose, that kind of stuff. And this is where you can start adding in more interesting things. One thing that usually comes up is power-ups. So you'll see sometimes when you break the brick, it'll drop you something that'll help you, hurt you, something like that. So one, for example, is to make your paddle bigger, so it's harder to drop the ball. Another one is like to make the ball go faster or make it go slower. These can be like beneficial power-ups or negative power-ups, I guess if you even call it that. Yeah, so here you can always, of course, ask the children to come up with their own ideas. And I even added a line here. If there are no ideas, there's like making the paddle bigger is a really good starter one. As well as that, there are, power downs, I guess. There are also health. And this project in particular uses a lot of operators. I think one of the things, advanced usage of operators and variables. So here, for example, you want to explain how costume number technically is an integer, keeping track of which integer costume you're on. So it could either be 1, 2, 3, 4, 5, no matter what you name it. And other things involving random. But this one is also very, very flexible. You can add in a lot of what you want. You can take out things that you don't want. Yeah, I mean, that's about it for Breakout. On to Space Invaders Plus. Basically is top-down shooter where you shoot straight up and there are things coming down at you. Here, there's a lot of cloning. Oh. Oh yeah, okay, so count. Okay. So if you're not familiar with cloning, I do recommend you take some time to become familiar with that, since cloning is kind of a weird subject in Scratch. In this case, let's see here. Right, okay, so once again, we have a bunch of steps for creating the base project. And in this game, I usually like to encourage creating a boss fight. So after creating all this, after defeating all the small fry, you can say like a boss fight stage approaches. And this one you can have a lot of fun with. Something you can always do is change the appearance of the boss, of course, the size of it, the health of it, how much damage it does. All of these variables are up to the children. Sometimes they'll create completely ridiculous things where the boss has like 1,000,000 health and you'll never be able to defeat it. But that's okay. Whatever it is, do encourage it at first. Just let them know, okay, yeah, you can totally do that with your code. And then you could also just say, I don't know how how possible that is to defeat, but you do have that ability. So you just want to let them know that their ideas, whatever they are, they can definitely do it in code. Whether or not it's like good gameplay wise, that's not really the focus here. Okay. Right. This one is a long one. I remember making this. Okay. So this one is pretty detailed. Hope you guys do enjoy reading this one. I strongly encourage you guys check out the example project for this one. I think it makes all the explanation in the lesson plan make a lot more sense. Okay, let's keep moving. Scrolling platformer. So, like I said before, the platformer was a pretty good introduction. Now, the scrolling platform is basically that, but a lot more complicated. So at this point, hopefully the kids have learned a lot more, I guess a lot more code that they can use and have been introduced to all the different types of blocks. And here is where you introduce using variables to keep track of their current position using world coordinates. So once again, there's like a presentation here, very, very useful. For creating the actual scrolling effect, which is once again the main part of the project. The rest of it is mostly up to the kids. Here, this one can be this one's usually going to be a lot more fun compared to the first platformer because the kids know a lot more. So since they know a lot more, you can create a bunch more wild things. One thing I think I did in my class before was burnable platforms. So ones that you could set on fire and then they would burn to a crisp. And then the next time you touch them, they would just collapse under you. That was a very interesting thing. I think we also created like pourable lava that was Minecraft inspired. But you can see that a lot of these things, while they might not make sense inside of the game, certainly things that you should encourage. And then when they create it, it's always fun to see completely random things come together. But all of it should work. Yeah, but this one is another relatively short lesson plan. Ooh, yeah, one thing I think was one of the cooler things that we did in that project was a mini map. So a mini map that gave you a full perspective of the whole map. Yeah, but all these things you can see are things you can add on. You don't have to add all of them in. You can add completely different things in, but whatever it is, you should keep adding things in to keep the kids engaged. Okay, so we got time for multiplayer. Multiplayer is very, very complicated. It is weird, and the code usually doesn't make a lot of sense. That's fine. But certainly before these units come rolling around, please do some research and learning into cloud variables. They are extremely finicky. One I could list endless problems that they have. So one thing that's really dumb, mind you, but you have to work around it, is the fact that they update one time every 10th of a second, which sounds fast, but when you're making a game, it's actually incredibly and pitifully slow. Another thing is this will create probably the most bugs you've ever seen in your life. One bug is it updates. So one computer might send out a message to update the cloud variable, and then the other computer also sends one out. If they're not timed correctly, they can overlap, kind of cross over, and they'll have different displays on both computers, ruins everything. And I think here in the intro and more on cloud variables, those two presentations, I talked about some of the terrible, terrible bugs here. And there's even a link if you want to read about that some more. But there are some ways that you can kind of get around this. These are some ways that I developed, so they're terrible. If you do find a way that gets around these problems better, do feel free to use them and even let me know. That'd be great so I could update these. I hate to be sharing things that aren't super effective, but they kind of get the job done, so I'm okay with it. Same with this one. Okay, so for the board game, this one I would highly encourage you to pick something that all the kids are familiar with. So usually that's something like Monopoly. It could be Candyland, Chutes and Ladders, that kind of stuff. Something that's relatively simple. I would consider Monopoly even to be slightly complicated, I guess. Chutes and Ladders is a pretty good one to go with. It could also be a completely original board game. But whatever it is, for the board game, the main thing you want to do is make sure that both devices that are running the project are able to display the same thing. And to do that, you're going to need to test. Testing requires you to have two devices or two windows on your computer. That's usually easier. You can split screen it. You can have, I guess, like player one on one side, player two on the other side. Or you can even ask for one of the kids to volunteer to be your helper, and have them test the game with you. Though I would say it's usually easier to bug fix doing split screen. I think that's the best idea. But to do split screen, you technically need two accounts, two Scratcher accounts, which is unfortunate, but I believe there is a way to get around it if you do one account on a window where you normally log in, and then the other on like an incognito window, you log into the exact same account. But since they're both technically Scratchers, you can play the game, I guess, against yourself, and that'll work out fine. I can actually show you one such thing as right now, actually. So let me find multiplayer or something. So this is one that I did quite a while back. Not super clean, but it works, I guess. So here, and then I open up another window, go to Scratch, I log in. We'll split screen it. So let me go ahead and let you guys see that. And let's see. Okay, so when you're testing, it's probably going to look something like this. Where this one controls player one, this one controls player two. So you can see if I'm clicked over here, it controls this one and it controls this one when I click onto this tab. I'm logged into the same account on both screens, so you don't have to make two accounts. That's great. But yeah, this is one way that you can test it. Unfortunately, this is about as smooth as you can get the movement to be without any interpolation or anything like that. But you know, this does work for a multiplayer game. It's mostly in sync. But yeah, there are a lot of limitations with the cloud variables, so you can do the best you can. Let me go ahead and get rid of this. There we go. Okay. So for the board game, it's a little bit more, I guess, relaxed with cloud variables since things happen in turns. So one person's turn happens, and then you could, I guess, broadcast each step individually, compared to the next unit, which is going to be some sort of a fighting game. And this one's actually pretty flexible. So fighting game, whatever you think that means, it could be, I guess, like a wizard battle. I don't want to say shooter because I know some things are sensitive with that, but you do something like top down, kind of like tanks, if you guys know that game. So it could also be something like Street Fighter, like I created back there. I think this is a Street Fighter-esque game where you have health and they punch and throw fireballs at each other. But this one's more, I guess, live. So the code there is slightly different, but it's still explained in the presentations. Okay, so nice, right on time. So at this point, does anyone have any questions?
So I'm trying to teach the Scratch Junior classes, and I
Mhm.
took this training course because I wanted to figure out how can I best prepare my students for the next step in Scratch.
Mhm.
Do you have any recommendations for like questions to ask to get people to start thinking about game design, just in general? Um, to provide students to just start getting into the creative building mode.
All right, absolutely. First, that's really cool that you're here for that. So to get them prepared, I think Scratch 1 does a pretty good job. And to get them thinking about games, I'm happy to say that usually it happens pretty naturally, just because most kids play games anyway. But one thing that might help them, I guess, become interested in creating them themselves is the question, what do you play at home? And do you think you could make that in Scratch? Or do you want to make that in Scratch?
Mm,
I haven't really thought about that, but yeah, that's a great question. Um, I think you said you teach Scratch Junior, right?
I still have to do my evaluation, but I'm
Okay,
almost through with the evaluation curriculum.
all right, awesome. Um, I mean, I think 0 1, most of the projects are not super interactive. Or they're kind of interactive, but not like as interactive as an actual game. Um,
I can see how because it's my first introduction to Scratch. When I'm thinking about programming, like, oh, we have like the loops with the repeat button, or the green flags with the start, or the timer. And so to just talk about the buttons in themselves as we use them, and how do you see those things when you're on the internet? Like, are there any is there any countdowns you interact with like an alarm clock in real life? Well, like, oh, this is how you do it in Scratch.
mhm.
So I'm trying to figure out how to create like a theoretical basis just to start imagining about programming before they go to the next level, because there isn't a lot
Oh,
of designing.
oh yeah, absolutely. One thing I like to do, for example, when I explain conditionals, like if thens, it's like, oh,
Mm,
if you're hungry, you go get a drink of water, something like that, or not
okay.
hungry, thirsty. But um, that happens a lot in kind of the game sense as well. So if you're trying to prepare them for creating games, you could be like, so you know how in order to eat an apple, you have to, put it in your mouth or like get close enough to it to like pick it up. So in a game, obviously we should have to be close to the apple as well. So something like that. Um, and things like asking them to create, I guess, an input key, maybe like E or something to interact with an apple, something like that. Um, I don't know. But the best thing to do, I think, is to just connect it to games that they already play. It's a little
Got
harder if they don't play any games.
mm,
Um, but you could say like, oh, in Minecraft, you know how you can do this? Well, we can basically do the same thing here. That usually clicks pretty easily.
okay. Thank you.
Mhm. Um, any other questions? Okay, so in general, as closing remarks, while I was doing this training session, I was making a pretty broad assumption that you guys were familiar with Scratch. Um, and if you aren't already, I strongly recommend you do some projects on your own. The best way to learn coding is to do things with it. So you could even use these projects as an example. If you want to say, okay, so let's say I'm pretty new to Scratch, but I want to teach it. That's great. Maybe let's say I'll start with the platformer game, and I just want to get familiar with different types of code and how to use it. Move on. Maybe you can go pretty quick. You can just like speed run these, but you just want to be able to think of ideas and how to create them on the fly by the time that you're actually teaching this class. So if a kid says, I want to create an axe to chop down wood, I want to be able to think of something to do that. Okay, so let's create a sprite, create this code, blah, 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 and that will get you to what you want. Um, but of course, in order to do that, you have to be familiar with Scratch and everything that comes with it. A few things that you should be pretty prepared for. Um, here, I would just say it's generally Scratch. Here, be very familiar with variables. And here, you want to be familiar with cloud variables, uh, especially. So I guess worst case scenario, if you did come into this with like a medium understanding of Scratch, you still have like as you're teaching these, you have time to prepare yourself to teach the next few units. Though ideally, you're ready for it the whole way through. Okay. Any other questions? All right.
I do have a question. Like I know other programming languages by having like gone with Scratch. Like how long does it take for like somebody to catch up? Will be like I'm looking at your site. It says like 2 weeks to study material. So I don't
Oh,
know what.
did you say that you're already familiar with like other types of programming languages?
Yeah, I know Java. I'm trying to get certified in Java, and I know Python and
Okay,
stuff.
awesome. So if you're in that boat, I think you'll have a pretty easy time with this. Most of
Okay.
Scratch is in very plain English. Um, it's pretty easy to understand and relate to whatever it is on Java, on Python or whatnot. I feel like if you just look at it for a little bit, especially the control, sensing, that kind of stuff, comes pretty naturally. Stuff that you might want to just look over is like the niche looks that are specific to like Scratch sprites. And I guess familiarize yourself with the actual Scratch interface. So that could be, creating, drawing, deleting sprites, copying code, duplicating things, that sort of thing. Clones are one thing that I think are pretty unique to Scratch. Well, actually, not necessarily. Nope. But yeah, you should take a look at things that are specifically mentioned in the lesson plans and whatever you see in the example project. I feel like if you took a look at it, you just read through it, you'd have a pretty good understanding already. But yeah, you can take a look at it again just to make sure. As for the time frame to learn that, if you are familiar with a programming language, I really do think that a week or two is really all you need.
Last thing, I didn't know the site. Like I don't even remember I had like a login to the site.
The ThinkLand site?
Yeah, I reset my password, but I don't recall. I don't know if I did it like a month ago or something. But
Okay. I would contact somebody on the tech side of that.
I'm in already, but it was just I didn't.
Oh yeah. I mean, you got time for that. That's not too big of a deal.
All right.
But I would want everyone here to save that link if you don't have access to that right now. All right. Anything else? If not, I wish you guys.
Just one last question.
Yeah,
Is there a
go ahead.
way that like the kids can like put in like is there like a GitHub for this? Can they share it or is it through the account only?
Hey, what? Oh, sorry.
Usually when you like with like open source stuff, you put it on like a GitHub and you can like
Oh, okay.
brag about it on somewhere.
Okay, yeah. So for Scratch, creating projects, let's say I created a new one. I don't know what that is. Create a new one. So here, it's all stored on the Scratch website. So when we go and share it, anyone that searches this specific name or searches for my profile can find this listed online. So yeah, no need to like post projects anywhere. It's going to be on Scratch. Okay. I wish you guys an awesome rest of your day. And good luck in your evaluations.
Thank you.
Mhm.
Thank you.